Good morning, class. Welcome to Calculus BC. All right, get to work on that worksheet.
This is easy. I got this. Wait.
I don't know any of this. We'll help you.
Yay!
Derivatives.
Rules for differentiation. Derivative of a constant function. If f of x equals c, then f prime of x equals 0. The sum and difference rule. If f of x equals g of x plus or minus h of x, then f prime of x equals g prime of x plus or minus h prime of x. The constant multiple rule. If f of x equals a times g of x, then f prime of x equals a times g prime of x. Derivative of a power. If f of x equals x to the n, then f prime of x equals n times x to the n minus 1. Product rule. If f of x equals g of x times h of x, then f prime of x equals g of x, h prime of x, plus h of x, g prime of x. First times the derivative of the second, plus the second times the derivative of the first. Quotient rule. If f of x equals g of x over h of x, then f prime of x equals h of x, g prime of x minus g of x, h prime of x all over h of x squared. Low d high minus high d low over low low. Derivatives of trig functions. The derivative of sine x is cosine x. Cosine x is negative sine x. Tangent x is secant squared x. Cosecant x is negative cosecant x cotangent x. Secant x is secant x tangent x. And cotangent x is negative cosecant squared x dx. Chain rule. Derive the middle term, the inside, and multiply it to the entire term. Steps to implicit differentiation. Number 1. Take derivative both sides with respect to x. Collect terms with dy dx on one side of the equation, everything else on the other side. Factor out dy dx and solve for dy dx. The derivative of e dx is e dx dx. The derivative of a to the x is a to the x ln a dx. The derivative of ln x is 1 over x, and the derivative of log base a of x is 1 over x ln a dx.
Alright, so using the equation given earlier, we know that this can be negative 5 cosecant squared quantity 2 over x. And with chain rule, you have to multiply it by negative 2 over x squared. And how we got that was taking 2 over x and applying the quotient rule to it, getting x minus 0 or x times 0 minus 2 times 1 over x squared. And to simplify this, hold on. Alright, here we go. And to simplify this, it is negative 2 over x squared. Now we can plug it back in and simplify with dy dx equals negative, it's positive now, 10 cosecant squared quantity 2 over x all over x squared. And there you go. Alright, so we're doing the derivative again. So dy over dx equals 1 over x squared, and the chain rule, multiply by 2x. And to simplify, it's dy dx, and we can cancel out the x's, and now it's 2 over x. Okay, this one's really easy. All you have to do is have the e to the 2x, and the chain rule, multiply by 2. And make it pretty, 2 times e to the 2x. For the last one, we have to do one of the equations that we learned earlier, and it's 2 with the chain rule times 3 to the 2x times ln of 3. Simplify it a little bit, 3 to the 2x times 2 ln 3. And there you go. Great, so this is an example of implicit differentiation. First, we take the derivative of both sides, x squared plus y squared, and the derivative of 25. Alright, so now we have 2x plus, and because it's with respect to x, we have 2y times dy over dx. And that equals, well, it's a constant, so it's 0. Okay. Now we move the 2x over to the other side, so now it's 2y. Oh, and don't forget the differentiable, dy over dx, very important. And then that equals negative 2x. Okay, so now we want to get the dy dx by itself. So we have dy over dx equals negative 2x over 2y. We can cancel out the 2's, so it's dy over dx equals negative x over y. And that's it.
Antiderivatives.
A function f of x is an antiderivative of f prime of x. For example, f prime of x equals 0, f of x equals c, a constant. If f prime of x equals 2, f of x equals 2x to the c. If f prime of x equals x to the first, f of x equals 1/2 x squared plus c, in general terms, x to the n plus 1, all over n plus 1 plus c.
Okay, so anti-differentiate the derivatives. Okay, so we have f of x equals, and that's x cubed minus x squared plus x plus c. Very important. Okay, and don't forget the c. Very important. Okay. So now we have f of x equals, and this is really easy, negative cosine x. Okay, and oh, and don't forget the c. And there you go.
Concavity.
Okay, find the local extrema by locating where f prime of x equals 0 and f prime of x does not exist, and the endpoints. Use a sign chart to test if the sign changes on each side of the local extrema. This determines maximums and minimums. To find concavity, search for where f double prime of x equals 0, f double prime of x does not exist, and the endpoints. Use sign charts like mentioned earlier. Concavity can be concave up, slopes are increasing, or f prime of x is increasing, or concave down, slopes are decreasing, or f prime of x is decreasing. This is best described by example.
Okay.
Examples of concavity. So we're given an equation, y equals 2x to the 4th minus 4x squared plus 1, and we're going to find where it's concave up and concave down, and to find that we need to find the second derivative. So here's the first, and here's the second, and we find out it's 24x squared minus 8. And we're finding where it's concave up and concave down again, so we're going to find where it does not exist, where f double prime equals 0, and the endpoints. And we figure out that it exists everywhere, and the endpoints, there aren't any that are given, so we're just going to find where it equals 0, and we figure out that it's plus or minus 1 over rad 3. And then we're going to do a sign chart to figure out where it's concave up and concave down. So we'll put positive 1 over rad 3 and negative 1 over rad 3 on the sign chart. And to find where it's concave up and concave down, we're going to use the second derivative, and we're going to plug in some numbers in between. So we're going to use, let's use negative 1, and we'll use 0 because it's in between them, and we'll use positive 1. And then we're going to plug it into the second derivative, so 24 times negative 1 squared minus 8, and 24 times 0 squared minus 8, and I'll just separate this, and 24 times 1 squared minus 8, and we're going to figure out that the first one is positive, the second one is negative, and the last one is positive. So from that information, we get that the -1 is concave up, the 0 is concave down, and the 1 is concave up. So we'll just write it out in the form that we're supposed to write it out in. And so the concave up will be from -infinity to -1 over rad 3. And we'll use the other one, and it's 1 over rad 3 to infinity. And where do we write the down one? We'll just write it, we'll write down this one's up. And we'll write the down one over here, D-O-W-N. And that one is from -1 over rad 3 to 1 over rad 3. And that's the answer.
And then it like shows the marker cap.
We'll help you. Oh, okay,
Okay, well, don't.
yeah, okay.